Hi, welcome to another edition of Calculus 3. Today we are going to talk about some advanced formulas related to tangential and normal unit vectors. Let's go ahead and take a look at that. The set of formulas that we are going to cover today are going to be a bit more convoluted than the ones that we had before, so they require a bit of extra practice. They're kind of like this picture here, high mountains and such. Okay, let's go ahead. Our main aim is to talk about the normal vector we talked about last time. You remember, in general we were talking about moving on a curve in space. So we have r as a function of time. While we are going on this curve, we have some velocity vector which is r prime, and our acceleration is r double prime. These are typically easy to calculate, r prime and r double prime. We define the unit tangent vector by simply dividing velocity with speed. We get a unit vector in the direction of velocity, which is tangent to our curve. The principal unit normal vector was defined as a ratio of the derivative of this to its length, t prime over absolute value of t prime. And this is a straightforward definition. However, in calculation it becomes a bit convoluted to take this and actually take a derivative of it. So sometimes we want to have alternate formula that's going to be a bit more straightforward. Well, this is the alternate formula I'm going to talk about today. On the face of it, it looks more complicated than that, but it's a bit less error prone and perhaps more straightforward than what this one is going to be. What does this one say? Take the velocity dotted with itself. Now you have a number multiplied by acceleration minus a dotted with velocity. Now that's going to be a number times velocity. When you subtract, you get a vector. Take this vector and divide by its length. You get a vector that's going to be same as the n that you want. Now this is one of the homework problems in the text, and we want to go ahead and show where does this formula itself come from. Let's go step by step. Step 1 is when you want to take this description and take a derivative of it, you would need the derivative of speed. Let's go ahead and calculate what that one is. So we start our journey by asking, what is this expression? Derivative of absolute value of velocity, or derivative of speed. We suspect it has to have something to do with acceleration. We have actually seen this thing once before, but let's go ahead and calculate it mathematically. So what is the absolute value of v? Absolute value of v is v dot v to power over half. Is that right? That's the absolute value of a vector. And then we want to start with this and take a derivative of that. Well, how do you take a derivative? Exponent times the derivative of the base. Now the base is a product, so if we apply the product rule, derivative of first dotted with second plus the first dotted with derivative of the second. Finally, the base to power of 1 less than the old exponent. So we'll have v dotted with v to power of 1 less than that will be minus half. Now these two expressions are the same, so I'll have really 2 v prime v, and then when I divide it by 2, well, just I'll have v prime v. So let's go ahead and write this. That is v prime dot v, and v dot v to power of minus 1/2. If I put it in the denominator, it will be to power of 1/2. And of course v prime is just the acceleration, and this is just absolute value of v, which is the speed. So out comes the tangential component of acceleration alongside the velocity. So this is simply a sub t, or tangential component of acceleration. Okay, now we are in a position to actually carry out this. This is the definition of what the unit normal vector, the principal unit vector is. Now, to carry this out, I need to have the derivative of t itself, and then I have to normalize it. So I start with t. So I start with t, which is v velocity divided by speed. So what is t prime? We are practicing differentiation really, but for vector quantities. As any other formula you have seen, you have to apply the quotient rule, derivative of numerator. So derivative of numerator times denominator minus derivative of denominator, well, derivative of that speed times the numerator divided by denominator squared. Next step, well, v prime is just a. Absolute value of v is just your speed minus v prime, well, we just found v prime, let's write it, a dot v over speed times v, the whole thing divided by absolute value of v squared. Well, I take a common denominator in the numerator. Let's see what happens. I'll have a times v absolute value times another absolute value, product of these two, minus, let's put these two in a parentheses so we don't mistake what is meant by there. Then this absolute value multiplies by this one, so I'll have v cubed. Well, absolute value of v times absolute value of v, that is just v dot v. So let's write it that way. So I'll have let me write a first, then v dot v. Let's write this one in the same style. It doesn't matter where you put the v first or since. So minus v times a dot v over v cubed. So that is an interesting formula by itself to have on the side. T prime is equal to a v dot v. So v dot v is a number times a, that's a vector. V again is a vector. A dot v is another number, and then the whole thing divided by cube of speed. Now, what did we say what definition of n was? Definition of n is take t prime divided by the length of it. Normalize it like this. So if I take this and divide by the length of the whole thing, and in the division this number is going to carry out, it's going to drop out, and I'll have the ratio of this divided by length of it. So it's going to be a times v dot v minus v times a dot v over the length of this whole thing. So I have to put the whole thing in absolute value. And that is the formula we had at the very beginning. Okay, we are done. There is another formula in vector calculus. Probably you have seen this in calculus 2. I write it and then I write the equivalent version of this. And the formula is the triple cross product. If you have a times, the a, b, c are just any three vectors, have nothing to do with the velocity, acceleration, or anything. Any three vectors you have a, b, c, you can write it as b times a dot c minus c times a dot b. One of the formulas that are rather hard to memorize and kind of lengthy to prove, but the proof is straightforward. You can write the components, takes a while, and then you see it. So it's ABC, and this one commonly pronounced as back minus cap, just so that it helps us to memorize the formula. And the first item is always outside of this parentheses. So A cross B cross C is B times A dot C minus C times A dot B. With that help, we can see that this numerator turns out to be V cross A cross V divided by, well, this is the same thing in absolute value. Now, as far as computation is concerned, this is easier than that one to carry out, but it's just interesting to know that these are the same thing, so we can put it in our list of formulas that we know about vectors associated with a curve. So the formulas in this section are a little bit more advanced than the ones that we have seen before, but it's not really that bad to apply. So you take your r, calculate the velocity by differentiating, calculate your acceleration. Now v dot v, that's a dot product of this with itself, that's going to give you one number. A dot v, that's another number. This number multiplies by v, that number multiplies by a. You get a vector, and the normalized form of that will be same as n, and this typically easier to carry out than the original definition. So that was one of the homework problems that I thought deserves its own place. So this lecture supposedly going to help you with some of the problems that you are going to see in your homework. Okay, until next time, good luck and God bless.